I decided to conduct my DSARI project on wind energy. I was curious about its use in Minnesota, so I'll be going on a tour of the St. Anthony Falls Laboratory to get an idea of how we use wind energy in our state. To begin, I have done some background research on wind energy and its uses. According to the American Wind Energy Association, wind energy, or wind power, refers to the process of creating electricity using the wind or airflows that naturally occur in the Earth's atmosphere. This kinetic energy is captured and transferred into electricity using modern technology. So how does wind power actually work? Essentially, wind blows past wind turbines, and the kinetic energy in the wind makes the turbines move. These rotors on the wind turbines are connected to a generator, which creates electricity. Each turbine has 2 to 3 blades that are connected to the rotor. The rotor is connected to a low-speed shaft, which spins at about 30 to 60 RPM. Next, there is a gearbox that connects the low-speed shaft to a high-speed shaft. The gearbox increases the 30 to 60 RPM speed to about 1,000 to 1,800 RPM, which is the speed needed to generate electricity. The energy then reaches the high-speed shaft, which drives the generator of the wind turbine. The generator produces 60-cycle AC electricity, which means the energy is running at 60 Hz in an alternating current. Within the wind turbines, there's a controller which keeps track of speeds. The turbines do not operate with wind speeds greater than 55 miles per hour. There's also a pitch system in the rotor, which also monitors these speeds in order to receive maximum electricity. The wind energy captured in the turbine is then distributed to the power grid. I also did some research on the St. Anthony Falls Lab and its work on wind power. The SAFL is located on Hennepin Island on the Mississippi River and is run by the University of Minnesota. They also have a field research center located in Rosemont, Minnesota, where the research on wind energy is primarily conducted. Their wind energy research is conducted to tackle a broad spectrum of wind energy-related problems. My trip to the SAFL included 30 minutes of prep time, an hour of driving round trip, and the hour-and-a-half-long tour. So I've just arrived at the St. Anthony Falls Laboratory for my tour for the project. I'm excited to see what they have, and I'm excited to hear what they have to say about wind energy. The beginning of the tour provided us with some background information about the SAFL. They do a lot of work with renewable energy, mainly hydroelectric power, but also wind power. The first stop on the tour was the wind tunnel. The experiments conducted in the wind tunnel are based around wind power and wind energy. The tunnel is a research-scale model of a wind turbine, meaning it contains all the same components but has more experimental value. The wind tunnel can test winds up to 100 miles per hour or hurricane-speed winds. This is done in order to assess potential damage from hurricanes as well as how to create wind-proof buildings. The floor of the wind tunnel can also be adjusted to take a look at soil moisture and vegetation and how that can be affected by wind and erosion. As Nick, our tour guide, was discussing the wind tunnel, he also mentioned the large-scale wind turbine that the SAFL owns that is located in Rosemont, Minnesota. This is a turbine that is used for research and can easily be modified and controlled. All of the power that is produced by this turbine is sold to the power grid. According to Barbara Heitkamp, the communications specialist at the SAFL, over the last 5 years, the wind turbine has averaged 3,000 to 4,000 megawatt hours of power, which can power anywhere between 280 to 400 residential homes for a year. According to the Minnesota Department of Commerce's Renewable Energy Updates of November 2018, at the end of 2017, Minnesota had 3,700 megawatts of installed capacity from wind turbines and 8.7 megawatts of installed capacity from small wind turbines, for a total of 3,709 megawatts. The American Wind Energy Association tells us that 1 megawatt of power can provide 525 homes with electricity. Within the last 5 years, the SAFL wind turbine has generated a significant amount of power in terms of all of Minnesota. On a larger scale, we would need approximately 3.9 million wind turbines to power the entire planet with electricity, according to Business Insider. This would be possible if each turbine could produce 5,625 megawatt hours a year, at least 1,265 megawatts greater than the SAFL turbine. In addition to the SAFL's direct work on wind turbines, they have a portable lab project called Merle. This is used to test how wind turbines are affecting eagles due to their noise. Scientists want to preserve habitats to the best of their abilities. To conclude, the SAFL and Xcel Energy are doing a lot of important research on the future of wind power. The SAFL's work teaches us how wind affects our planet and how we can use wind power to our advantage.